Hi all, welcome back. Hi Raghavendra.
Hi, Amber.
So this is the last leg of the demo. Now
Yeah.
the entire demo has been set up, in terms of various components that need to go in play. This is where we come at a juncture where we will actually migrate, from A to B, the SockShop application from our EKS cluster to EKS-Anywhere cluster, right? Allow me to share my screen and I'll walk you through what's going to happen and what's the current state. Let's establish the current state also, a quick.
Mm-hmm.
So you can see that we have now in play the EKS cluster, which is already set up.
Mm-hmm.
And the CSI drivers are set up along with the EBS volumes.
Mm-hmm.
SockShop application has been already deployed, and these exist as PVCs on the EBS storage, right?
Yeah.
Again, the SockShop application is a polyglot application, so you saw 6 PVCs, and we'll kind of observe them again. At the same time, we have our EKS-Anywhere cluster set up on my virtualized environment, and then it's already integrated via the CSI drivers with our power store array, right? At the same token, we have already, gone ahead and integrated our data domain virtual edition, which is residing in AWS, with our on-premises Power Protect Data Manager.
Yeah.
In tandem, they will both orchestrate the entire workflow in terms of moving the SockShop application from EKS cluster to the EKS-Anywhere cluster, right? Along with all the assets and everything else, asset sources and metadata and whatnot in the application state. Let's begin by I'll give a quick glimpse of where we are from a application standpoint. This is our Kubernetes cluster in EKS running on AWS. So I'm gonna just display this kubectl get nodes. Sorry, this is our EKS-Anywhere cluster.
Anywhere. Yes.
The EKS-Anywhere cluster.
Yeah.
And the other session that I have opened up here is the EKS cluster, right? You can see this one, right? So we have 2 sessions opened up. Let's see on the EKS-Anywhere cluster, EKS cluster, get pods, -n, SockShop. So you can see all the pods are running here. kubectl get PVCs, -n, SockShop. And we can see the 6 PVCs which are running with a 1 gig capacity through the EBS storage class, right?
Yeah.
And at the same time, we do have our ingress to reach the SockShop front end. So ingress -n SockShop. So you can see that this is available to the NLB network load balancer address here. The host name for the front end is sockshop.thecloudgarage.com. If I do a ping here, okay, this will translate into this particular IP address, 105.109. Let me go to my host file and let me change the, it's already done, or let me see. Okay, let me change this one, the IP address again. Okay. So I'm editing the host file so that I am able to reach my sockshop, thecloudgarage.com through this IP address, which is resolved to the DNS hostname of the network load balancer, right? Now, this is what it is. At the other end of the spectrum is the EKS-Anywhere cluster. So you can see the 4 nodes here. Yeah. We can also see them in the vSphere console here. Go here quickly. So you can see the 7 nodes under test EKS-Anywhere cluster. The same nodes, which are the 3 etcd nodes, the 2 worker nodes, and the 2 master nodes, right? So, and we can also, like we said, in the EKS console, we can see this. We have both the clusters actually up and running. This is an optional integration for the dashboard for EKS-Anywhere. While EKS cluster anyway will be present here, right? We can see both the clusters are running the same Kubernetes version, and for one, the provider is EKS, the second one, the provider is EKS-Anywhere, right?
Yeah.
When we are here, let's also go and visit our SockShop application, okay? sockshop.thecloudgarage.com. You know that we had, already. So I'm on my Chrome browser. Okay, I'll go to the same browser window where we had, yeah. So you can see this, the sockshop.thecloudgarage.com. And we already have one user which we have created here. And I will right away log in with that particular user ID, number, and the password for that. So the login is successful, right? And in the accounts, we can see that my order is reflected here. So this user ID combined with this order ID resembles the state of the application data, which will migrate the application from A to B, right? Okay. Let's note C0D is the order ID, the last 3 digits. We'll take a note of that. This is, C0D. Okay. Now I'll head back to my Power Protect Data Manager, and we can see here too. We have now integrated both the clusters we have discovered. So if you see the videos that were actually used for the demo setup, you will see how did we actually discover these clusters and presented them as asset sources under the Kubernetes scope for Power Protect Data Manager, right? So that's where we stand now. The assets have been discovered in Power Protect Data Manager. So if I say C4 EKS AWS-1, we can see that all the namespaces that are actually a part of this cluster, you can see the SockShop application is there, right? And it's basically largely unprotected. All the assets are unprotected and this is under C4 EKS AWS-1 cluster. You can see it here, right? The cluster name. And at the same time, if I actually see C4 EKSA V-1, we can see that for this cluster, these are the namespaces that have been discovered, right? Including the PowerStore pods and all that actually. You can see that there is no SockShop namespace here. So now the clusters are discovered, they are ready. And what we will do is to start with, I will first create a protection policy. A protection policy is a logic of sort to basically capture the state of the application as desired, right? From a particular cluster, let's say, in this case, it's the EKS cluster. So I'm going to name this policy as SockShop 1, for example. Type of the policy is Kubernetes. Okay. And we will say next. We will select crash consistent. And then we need to add a scope of assets that are discovered, through Power Protect. Now, in this case, what we are going to do is we're going to search for the asset SockShop, which is the namespace. Yeah. So you can see the namespace here, SockShop. And while we are at it, we will also describe the state here. You can see that this is the namespace that we are talking about. And this namespace, as we have iterated in the previous videos, has these entities in the namespace, mostly the 8 microservices, the 6 data services, a TLS secret, and the English resource, right? So this is what we will, when we say that we are creating a policy to protect this namespace, all that you saw on that screen will be protected actually, right? That gives a very wholesome approach to migrating an entire application as opposed to an individual resource object inside of Kubernetes, right? And all that. Let's click on next. I can add multiple namespaces if I want to create a single backup policy for multiple applications or cross-dependent namespaces. But here, everything that we need for SockShop is inside of that. Now, where does this particular snapshot or the backup get stored? So we'll have to actually add the backup. In this case, I can do it on my local or the on-premises data domain, or I can do it on the DDVE that we set up in AWS, right? Let me also connect it back. Visual here. Yeah. So you understand where we are going to store this backups actually, okay? Now we will select the DDV, the cloudgarage.com, and we will select the storage unit that we defined as a logical entity within that data domain virtual edition, right? So I'm going to select that. And then we can, depending upon the RPO and RTO needs, we can always scope in, for how long how the backup frequency will be, for how long the backups will be stored. There's also an SLA in terms of, we can actually provide for the, consumers of data domain. Plus, I can also do a retention lock in terms of, so that accidental deletion doesn't happen and all that. We'll talk less about that. We'll focus on the demo requirements. Let's say in this case, we will back up every 12 hours and we will retain for 1 day. Just an arbitrary guess there. Okay. Now, there are some other elements that we can actually do in terms of actually replicating the backup itself. In case your primary backup, storage unit is lost and all that we can define. At the same time, you can do cloud tiering in terms of archiving the backups and things like that for long-term use. Actually, we'll leave this as is as of now. So our backup is defined, the target, and then we will move ahead with the policy creation. This is just a nice summary of the policy. And once we hit finish, what will happen is that on the EKS cluster, okay, this is the EKS cluster. Yeah. On the EKS cluster, you see as of now, PowerStore is running PowerProtect is running a controller. Okay, this controller was deployed here as a part of the discovery process. That's how PowerProtect will actually do all the backup and restore jobs. This is the main logic which is responsible to do all the orchestration and execution on the Kubernetes cluster, right? At the same time, we had, by virtue of deploying or discovering the cluster, it also deploys Velero, which is actually the underlying provider for many different activities regarding the backup and restores. So we can see that there is a Velero pod also running here. In combination, both of these actually would serve to create the required or execute the policy, and that gets executed as a set of CRDs. So if I quickly look at the CRDs which are there in this EKS cluster, you can see that there are application templates.powerprotect.dell.com, backup jobs, backup. These are all custom resources which are being defined so that once we submit the policy and execute it, custom resources will be created by PowerProtect controller to actually initiate these backup and restore jobs. Actually, okay. We'll focus a little on this a little less, and then as we'll see the actual execution, and then we'll infer from that. Okay. So for now, I'll just say finish on the policy creation. Once I say finish, it will actually do nothing unless I start the execution or when the next frequency cycle hits. Actually, right? Mm-hmm. Let it get defined properly. So we can see that the policy has been created, SockShop, okay? And if I click on the policy, I can see various things in terms of, the backup schedule and things like that. Also, you can see the asset that has been protected here or will be protected actually. And we can see that this asset is, SockShop, the namespace, the cluster is this, and whatnot, right? Now, let's head back to the jobs. Now, when a backend system job would have actually started in terms of configuring the policy, right? So that's completed. You can see that. So the policy is fully defined now, but as of now, it's not executed, right? So at this stage, we will go ahead, click on the policy. Either we wait for the next run of the automated run of the policy, or we say protect now. Okay. So what are we doing? We are protecting. And which assets? All the assets covered by that policy. So in this case, there's just one asset, right? And under the policy, the only asset that is there is the SockShop namespace. If I had multiple namespaces covered by this policy, I can either do all assets or I can custom, select the assets or the namespaces. Now I'll click on next. So, okay, I'll go for a full backup or a synthetic full. I can do either one. There are obvious advantages to synthetic full. For now, we'll keep it as full. And then that's about it. I mean, you can see that if your setup is done and you are in a day 2 operation, right, where you have to either manually for whatever reason, or in an automated way. You have to actually run the policy. This is about it. You can just say protect now. And when this is done, you can see that a job has been created. And if I look at the job details here, you can see that here the initial baseline of the manual protection has been started. Okay, ignore this for now. Now we will focus on this particular job. Okay. So we can see that the protection for the asset it's started, and when what happens as a result of this policy execution, if I look into the step log, you can see there is a progress of 1%. It is verifying the storage location resource, which is the data domain virtual edition. It is queuing the backup on the Kubernetes cluster, okay, which is in this case the EKS cluster. It is preparing for backup and then backing up the metadata. After that, it has already defined the set of tasks it will be executing. And you can see in the scope of those tasks, the first task is, after backing up metadata, is the CSI snapshot.
Yeah.
Second, yeah, CSI snapshot of the PVCs. There are 6 PVCs that it will actually take a snapshot of. And these are all temporary snapshots. It will be deleted from the cluster so that you don't end up in using your space. Once the snapshots are created, it will actually start moving the data of those particular PVCs via the snapshot to the data domain virtual edition for a backup that will be actually stored as a backup, for retention purposes. So you can see that, the process has already started. This could take anywhere between, 10 to 15 minutes, depending upon the size and scope of the, the data, as well as the network and things like that, right? So just while this is happening in the background, we'll monitor this. At the same time, I wanted to highlight this fact here. Let's look at what is happening in the for protect namespace, which is the controller namespace. You can see this, right?
Mm.
And if I say kubectl logs, okay, or I can first, let's also see kubectl get, is it backup job? Let me see.
Mm.
You can see that
It's starting.
Custom resource as a part of the CRD. Now, when we have created or ran the policy, a dynamic CRD creation has happened, which is called as under the category of a backup job. Now, this is not a standard Kubernetes object. This is a CRD. So, and the name of that you can see is prefixed with sockshop, intending that, this is how the backup job will be running. If I say kubectl describe backup job, and the name of the backup job, we'll not go into too much details, else, this becomes like a deep dive. Right now, we'll focus on the high points here. So you can see that the same step log that you were seeing is seen here also. So, and how does it actually define the backup job? It's a set of attributes that construct the variety of the job and the scope of the job and things like that, actually. Okay. And you can see that there's a log message here. Just want to highlight successfully backup namespace sockshop metadata with Velero. So that was at a stage where the step log showed that the metadata has been successful, right? And now let's focus on, we can also get some more insights. kubectl get pods -n pod protect. You can see that dynamically, every time a data move happens, in terms of the snapshots are already taken now. Okay. Now, as a data has started moving actually. So for every PVC that will be moved, a C proxy pod is created that will actually enact, the data movement procedure actually from the temporary snapshot to the backup storage location, which is the data domain virtual edition, right? We can also see now a bit of log here, kubectl logs -n for protect. And since, say, 5 minutes.
Yeah. Started about 4 minutes back.
So you can see here, I mean, I don't want you to get all, messed up with this logs, but you can see that this is what is happening in the background. Back up this persistent volume and all the attributes related to that, right? Create snapshots. So the Power Protect, you can see that Power Protect controller is the one which is actually, doing the needful in the backend to execute that particular backup job that was actually initiated by the policy here, right? Now, like I said, I won't get into too many details here, but for every PVC that will be moved, a cproxy container will be created, and that's how the process will get finished actually, right? Let me see now.
You may have to refresh it, yeah.
Okay, it'll refresh on its own. But this will take a little bit of time because the pod creation and everything else, the data movement, it'll take a little bit of time here. We've elapsed about 6 minutes into the process. I expect it to last for almost 12 minutes. I'll pause here and then we'll resume when the thing is created and done.
Great.
So we can see roughly in about 13 odd minutes. Again, depends upon the size and complexity of the backup, but 13 odd minutes into the run, the backup job
We
is
see a green tick, right, number?
Yeah, and we can actually look into the details here, but largely speaking, what the step log will show is that, I've already explained what happened, preparing for backup, backing up the metadata, and then the CSI snapshots. Then the data has been moved from the cluster, from the EBS volume. That temporary snapshots have been created and moved over to data domain virtual edition. So now you can see that all the 6 PVCs have been moved, and then the deletion of those snapshots in the cluster has happened, and then the backup copy has been created. So as of now, we are good from a state standpoint. Now, if you look at the visual here, your data domain virtual edition is hosting that snapshot for the asset called as SockShop, right? And it's preserved. You can do 2 things from here. This also actually highlights the fact that, if you omit the right-hand side, which is the EKS-Anywhere cluster. I have a previous blog that we have written of how to actually do a cluster level or, a workload backup and restore. So if you omit the right-hand side here, which is the EKS-Anywhere cluster, at this stage, you can also do 2 things. Instead of just repatriating the workload, you can also restore, if something was to happen to your cluster or to the namespace, right? Or to a functional logic within the namespace or a database getting corrupted, you can safely restore it from this backup. The same process would happen, and I'll show you while we are doing the workload migration, that if you were to restore the backup to the original cluster, which means that this namespace will be fully resurrected. Okay. So the process of restore can be advantageous from a cluster protection as well as from a migration standpoint, right? And in this case, we are going to do a migration here. Okay, so let's look at back to the Power Protect Data Manager. So now this has been protected. Now, if I actually click on restore, you will see in the restore scope of assets, we will have this particular for Kubernetes. We will have, you can forget these 3. These are from my previous cluster, but you can see that the SockShop space is available, right? And I can just filter it out, right? Okay. So now what can be done is I can click on, now comes the part where we will do the restoration onto this cluster. Now, before we start moving these things here, I also want to take the opportunity to highlight that the Power Store array will be the bearer of all the persistent volumes, right? So let's look at the Power Store array here. I'm logged into my Power Store array console, and I'm on the storage tab here. Yeah, storage and volumes, and I can filter. And second, I can just filter and search for EKS-A. You can see that as of now, there are no volumes that are listed here, right? And I've already told you that the CSI driver has been integrated with my EKS Anywhere cluster, right? So we have the CSI driver, kubectl get pods -n CSI power store. We can see that the power store CSI controller and the node drivers are available here. And when the backup is restored in the EKS-Anywhere cluster, you will see that those persistent volumes, we can see it through kubectl. And at the same time, we will see those persistent volumes automatically created under power store. Okay, so we'll verify that as well. Now, the other fact that I wanted to highlight is that as of now, you can look at my host file. The sockshop application URL is targeting the network load balancer through this IP, right? Now, in order to test the backup, right, and the application state, I will hash this out and I will point the sockshop URL to my Metal LB load balancer, the advertised IP address, which is the internal private IP address. So as of now, I don't have kubectl get pods -n sockshop. There is nothing as of now, right? This namespace itself does not exist, for example. You can see that there is no namespace in my EKS-Anywhere cluster, right? There is no namespace called a sockshop here. Now, when the namespace gets restored, an ingress object is created, and that will actually let the ingress controller, the Nginx ingress controller, bind 172.24.165.21 IP address to the front end of the sockshop inside of the EKS-Anywhere cluster. Okay, so we'll do this edit. I've unhashed this entry for my host file so that when I type in the browser, I'm hitting the EKS-Anywhere cluster advertised service address. Okay, let's do this now. Come back to Power Protect Data Manager and say restore. Now, obviously, if you have a automated run that's going on as a part of the backup schedule, you will have multiple copies of the application state or the namespace or the asset being protected. And I can very well then select, depending upon the RPO and RTO needs, which is the copy that I want to kind of restore. In this case, there's just one copy, which is the full backup. So I'll let that be. Next. Now you can see this restore to original cluster, which in this case will be the EKS cluster in public cloud. So that's a classic use case of backup and resurrecting the application in the same cluster. If an eventuality wants to hit. In this case, we are migrating actually, right? And you can see I'm using the word migrating. The use cases could be migration, repatriation, or it could be any other distribution. Let's say you're moving away from EKS to another distribution actually. Let's say Rancher or whatever actually. In this case, it's EKS-Anywhere, but it's any to any migration. So any to any migration, we are restoring to an alternate cluster. And in this case, you can see that my alternate cluster will be the EKS-Anywhere cluster. I'm selecting that. I will select next. I can include the cluster scope resources also. Okay, so I'll select that. It's your choice. And at the end of the day, I can only restore the PVCs inside of the namespace, or I can restore the entire namespace and also get a little micro in terms of the select PVCs and all that. So for now, we will resurrect or migrate the entire namespace along with all the PVCs and all that actually, and the cluster scope resources also. Next. Now you see, if it was to the original cluster, the namespace is already defined there, right? But in the target cluster, which is the EKS-Anywhere cluster, I showed you that there is no namespace here, right? Power Protect will automatically create that namespace if I specify that please restore it to a new namespace. And it's that obvious fact that in the target cluster, that namespace does not exist. So I'm saying restore to a new namespace, although the namespace itself is same in terms of the name, right? Sockshop. So I'll select next. This is a very important point, and I think one of the most pressing challenges today from a Kubernetes data migration standpoint is that at one end, think of it and visually, at one end, your CSI, the data that is residing here, the storage provider is EBS, and it's based on EBS CSI. In the resulting cluster or the target cluster, there is a different CSI driver that's coming from our store array. Now, when you are moving data from A to B, the target storage class is also changing, right?
Yeah.
So it's not only a migration of sorts between the clusters, although the distribution remains the same, but the infrastructure as a service provider in this case is AWS, EC2. Here it's the vSphere and the virtual machines, right? So point is that you are doing infrastructure as a service migration. The underlying IaaS is also changing, plus the IaaS for storage is also changing.
Correct.
You get the point?
Correct.
So Power Protect gets me the ability to do this. So restore options, I can change the storage class simply because in the target cluster, EBS CSI does not exist, right? It's an on-premises cluster. Then I can actually go ahead and select for which PVCs and all that. For now, I've selected all the PVCs, and I can selectively actually, do a storage class selection. So target storage class, in this case, it will be all PowerStore ext4. But assume that you had multiple different storage arrays and different namespaces. One can go on PowerStore, one can go on PowerFlex or something else and something else, right? Now, I'll get this done. All the PVCs are selected and we hit next, and the final act is restore. So it's like it's the most easiest thing to do. Kudos to the team who has developed and built this whole orchestration workflow. In the back end, there is so much of complexity. All the heavy lifting will be done. But from the actual execution of the entire affair, it's just this. So restore. Once you do that, a restore job has been initiated, like a backup job. Now the restore job is, so you're manually protecting. This was the backup that we had taken, and now it's the restoring. Now the same process will follow. Right now you can see that this is at a 0%. As the backup job, restore job progresses, I will walk you through some of the observations there. So let it progress for a while and we'll come back. So we can see that 4 minutes into the restore run, we have almost 17% of the restoration operation completed. If we look into the details here actually now, and the step log, like we had a step log for the backup job, now the restore also has a step log, and we can see that it's locking the copy, the change copy, and then it's again verifying that the data domain virtual edition is available, the storage location. Then it's queuing the restore on the Kubernetes cluster. In this case, the Kubernetes cluster is the EKS-Anywhere cluster. And the job will be a restore job instead of a backup job. Preparing for restore. And you can see that it has already started restoring the persistent volumes. Catalog DB is done. Orders DB is done. What is in progress is basically the RabbitMQ, Session DB, User DB. These are all pending items. And finally, the metadata will be restored actually, right? While this happens, we can now look at, let me see if I'm on the right cluster. Yeah, this is the EKS cluster, right? EKS-Anywhere cluster.
Yeah.
So now, you can see that previously there was no namespace. Let's validate if, because the PVCs are created, the namespace also has to be created, right, for those PVCs. So you can see that the namespace has now come up. It's active for 5 minutes. That's the same time that our job has been running. So the namespace has been created. As a part of that namespace, what will happen is the pods won't get delivered first. Let's see, sock shop. You can see that as of now, there are no pods running. The first task it is doing is basically to restore the persistent volumes, okay? So kubectl get PVCs -n sock shop. You can see that the 3 PVCs have been created, and these are now the other 3 are in progress. This one has just been created actually, okay? The RabbitMQ. Now, the other thing that I wanted to highlight is how we observed from a backup job perspective, get pods -n power protect. Okay, you can see here now the session proxy, the DB proxy is happening. The power protect controller is running, but these are dynamic pods that get created for every PVC that will be created. Okay. So in terms of what is happening from a logs perspective, the same way we can actually get the logs, kubectl logs for this controller, -n sock power protect, and then since 5 amp. You can see that the restoration tasks are going on here, right? All the restoration tasks, and this is actually defined by the restore job. Like in the case of the EKS cluster, we had a backup job, CRD, custom resource. Here it will be get restore job -n power protect. You can see that there is a restore job, right? And this is the name of that job. And inside of this job is the specification for the restore. All the PVCs, what and what not. So we can describe this restore job. Let's do it here, kubectl describe. And we are doing all that. I mean, from a operator standpoint, it doesn't really, it's just to kind of, make sure that you understand the logic behind the entire execution. Otherwise, you don't even have to get into this kubectl context and all that. You can simply do everything from the GUI. That's what we did. The protection policy was ran to create a backup, and now the restore has been initiated. But we can do a little bit of observation, not too much, but a little bit, and just see what the restore job would mean. Sorry. kubectl describe restore job, and you can see that the status is also shown, but at the same time the spec of that job is also provided. So this is the spec of the job. This is what the execution will look like in terms of the Kubernetes definition, right? Because it's a job CRD, custom resource, presented to the power protect controller, and then it gets executed to do whatever it's supposed to be done actually. Now we will head back to our. So you can see that 65% of the backup has been completed. We will pause the video here and come back when this is fully successful.
Yeah.
So we can see that, roughly about 12 minutes into the restore operation, the restore job is a success.
Yeah.
So from an operator standpoint, from where I stand, I can see that, the SockShop application has been migrated successfully, from A to B, that is from EKS to EKS-Anywhere. We can look at the step log, and you can see that all the restoration jobs have the PVCs have been restored, and finally the metadata has been restored. Now metadata is basically the pods and every other thing that has to be kind of restored along with the PVCs. That is. Now let's look quickly at the resources that would have been created. So kubectl get pods. I am on the cluster, the EKS-Anywhere cluster. We saw that previously there was no namespace, and then the namespace got created. Now we can look at the pods that are running in the SockShop namespace. We can see that all the 15 pods that were present on the EKS cluster, we can do the same thing here. You can see that this is the EKS cluster, and the 15 pods are running here. Let's also verify that if this is the EKS cluster.
Yeah.
You can see that this is the EKS cluster. The 15 pods are running, and they have their PVCs, which is actually on EBS-SC storage class. Now, what has happened as a part of the restore operation? We have now the EKS-Anywhere cluster. The pods are running. And also let's verify kubectl get PVC -n SockShop. You can see that the 6 PVCs have been restored, and the storage class is Power Store ext4, right? Now, also let's verify if the ingress resource has been created so that I can access the SockShop application.
Yeah.
You can see that instead of now the NLB URL at this end, due to MetalLB and what we had deployed, The sock shop, the cloudgarage.com is available via the address 172.24.165.21. Now comes the moment of truth, right? The moment of truth is basically I have already edited my host file. You can see the NLB's IP address is hashed out. The sock shop, the cloudgarage.com is now available or mapped to this .21 address that we just saw. So let's just go into the verification stage. The first point I said is that I should not have to, re-verify the SSL certificate, because the TLS secret also as a part of the metadata has to be restored. Okay, so let's verify that. I'm trying to browse. You can see that I was not asked for the SSL verification.
And you're logged in.
Sorry?
And you stay logged in as Amber, right? You're not being logged out as well.
No, I will log out in this case. Let's say that, okay. Let's start in fresh, okay? So that, okay. Sockshop, the cloudgarage.com. You can see that I didn't have to verify the SSL private certificate and all that. I don't have to register. We said the first point of validation is that the user database has been restored. So I will log in. And in the process of login, I will use the same user that we created when the application was running on EKS cluster. Test activity. Okay, wonderful. So you can see that the state of application is also now, at least from a one single database, that's the user DB, it's there. I can now get into the account. You can see that C0D order ID has been restored, right? And I can actually go and just verify this here. You can see that this is the same order ID that we actually saw when the application was running on the EKS cluster. Plus my shipping address, invoice address is also preserved. So everything basically looks intact. The exact state of the application has been migrated. Okay. Now, basically the job is done in that case, right? So we come to the end of the demo, and conclusively we can say that, with ease, although we did a series of videos and describing how to actually set up this, the EKS cluster, the EKS-Anywhere cluster, and data domain and product. This video is more about how easy it is to orchestrate a repatriation task, especially when you are running stateful workloads on Kubernetes cluster. In this case, the clusters are running the same distribution, but it could be any to any in that case, right? With that said, thanks a lot, Raghavendra, for staying up with me on this call. And for all the audience, I hope it kind of makes sense, and it presents an opportunity for you to kind of understand how do you do multi-cloud migrations with Power Protect Data Manager and DDB, and how you can actually work with, hybrid cloud native platforms that Dell has to offer actually. I will just close the video with this final slide. This is the first slide that we had. And okay, we did miss out on one point actually.
Power store, right?
Exactly. Line storage. Although I showed it to you from the
application
kubectl standpoint, I am on my Power Store array. You can see that I have filtered out, the prefix EKSA, and you can see that the 6 volumes have been created here.
Yeah.
Okay. And you can see the logical used and the provisioned and all that. But the point that I want to also highlight is that the fact that, when Power Store is doing a restoration, okay, it's actually restoring the actual data. So note that, the asset size that is restored is almost 1.2 GB, while in total there are 6 PVCs, which are 1 GB each actually, right? In case of AWS, it does not allow for lesser than 1 gig of EBS size, so 6 GB. While it has been resurrected and migrated at the other end, the actual data which is actually stored on the DDB is just about 1.2 gigabytes. And that's what has been restored here. And we do have the Power Store array. Coming back to the conclusion, this is the first slide we started with, and I'll end it with the same slide. You have seen how our HCI and platforms can be used for hosting cloud native stack like EKS-Anywhere in this case. There are many more things you can do with these instrumented platforms. Plus, we have also seen how Power Store, in this case with CSI integration, can be used to host, cloud native and modern applications actually with persistent needs. Plus, we have done a full-fledged execution of multi-cloud data protection. So I hope it validates all the points that we wanted to cover. Thanks a lot. Enjoy the day and the evening.
Thank you, Amber. Yeah.
Cheers. Bye.
Bye-bye.